This is a ChatGPT moment for biology. Ex-Meta scientists develop artificial intelligence AI model that creates proteins that are not found in nature. The ESM3 model can write new proteins from scratch, opening up new possibilities for synthetic biology. That's frightening. Just as ChatGPT generates text by predicting the word most likely to follow in a sentence in a sequence, a new artificial intelligence AI model can write new proteins that are not naturally occurring from scratch. Scientists use the new model ESM3 to create a new fluorescent protein that shares only 58% of its sequence with naturally occurring fluorescent proteins, they said in a study published July 2nd on the preprint bioRxiv database. Representatives from EvolutionaryScale, a company formed by former Meta researchers, also outlined details January 25th in a statement. The research team has released a small version of the model under a non-commercial license and will make the large version of the model available to commercial researchers. According to EvolutionaryScale, the technology could be useful in fields ranging from drug discovery to designing new chemicals for plastic degradation. ESM3 is a large language model LLM, similar to OpenAI GPT-4, which powers the ChatGPT chatbot, and the scientists trained their largest version on 2.78 billion proteins. For each protein, they extracted information about sequence in the order of the amino acid building blocks that make up the protein, the structure, the three-dimensional folding shape of the protein, and the function, what the protein does. They randomly masked pieces of information about these proteins and requested the ESM3 predict the missing pieces. They scaled this model up from research that the same team was conducting while still at Meta. In 2022, they announced EMS-Fold, a precursor to ESM3, and predicted unknown microbial protein structures. And that year, Alphabet's DeepMind also predicted protein structures for 200 million proteins. Scientists subsequently pointed out that there are limitations to these AI models' predictions and that the protein predictions need to be verified, but the methods can still massively speed up the search for protein structures because the alternative is to use X-rays to map out protein structures one by one, which is slow and costly. ESM3 goes beyond just predicting existing proteins, however. Using the information gleaned from 771 billion unique pieces of information on structure, function, and sequence, the model can generate new proteins with particular functions. It was described as ChatGPT moment for biology by one of the EvolutionaryScale's backers. In the new study, the researchers queried the model to generate a new fluorescent protein, a kind of a protein that captures light and releases it back to a longer wavelength, making it shine in a new shade of green. These proteins are important for biological research who append them to molecules that are interested in studying to track and image them, and their discovery and development won Nobel Prize in Chemistry in 2008. The model generated 96 proteins with sequences and structures likely to produce fluorescence. The researchers then chose one with fewer sequences in common with naturally fluorescent proteins. Although the protein was 50 times less bright than natural green fluorescent proteins, ESM3 generated another iteration that led to new sequences that increased brightness, and the result was a green fluorescent protein, unlike any found in nature, dubbed ESM-GPF. These iterations, done in moments by the AI, would take 500 million years of evolution to achieve, the EvolutionaryScale team estimated. This by Tiffany Taylor DePhil on Live Science. Please leave your comments and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.